The Truthers. Today is April 21st, 2017, and we're live from Diana's house. I'm here with Diana, who's an expert physicist, and she's going to be teaching us about the different types of kinetic energy with objects at different moments of inertia. So Diana, please break it down for us what we're going to be doing today.
Okay, so what we're going to be doing today is calculating the angular kinetic energy and the linear kinetic energy, and comparing the proportion of angular and linear kinetic energy to the total kinetic energy of objects with different moments of inertia.
Did anybody else understand that? Just me? Okay, cool. So could you please explain to us in English, for us who don't understand your nerdy talk, what it is we're going to be doing today? Like, reiterate it.
So, first let me explain what physics is. Physics is the science used to explain how a ball rolls using complicated and long formulas and such.
Sounds interesting.
Okay, so what we're doing today is actually exactly that. We're rolling a ball, a tennis ball, a baseball, and a soccer ball, and we're calculating the angular kinetic energy, which is the kinetic energy, the moving energy it has as it rolls, and the linear kinetic energy, which is the moving energy it has as it moves in a line.
Alright, cool. So how do we get this started?
So the angular kinetic energy and the linear kinetic energy is equal to the total kinetic energy, which means that 1/2 IW squared plus 1/2 MV squared equals the total kinetic energy. The goal is to find the proportion of angular kinetic energy and linear kinetic energy to the total kinetic energy. We have the circumference, the time, the distance, and the mass. This is for trial 1 of the soccer ball. Step 1 is to find the radius of the ball. Using a string, measure the circumference of the ball by wrapping it around the ball exactly once and measuring the distance of the string. The circumference of the soccer ball is 68.7 centimeters, which using dimensional analysis, you get that it's 0.687 meters. The circumference is also equal to 2 pi r, so set 0.687 or whatever the circumference is equal to 2 pi r and solve for the radius. Step 2 is to use the mass and the radius to find the moment of inertia. You have to weigh the object and find the mass of the object, and then using the radius that was previously calculated, plug into a moment of inertia formula. A soccer ball is a thin spherical shell, so the formula for the moment of inertia is I equals 2/3 mr squared. And you get, in this situation, that the moment of inertia is equal to 0.0033 kilograms times meters squared. Step 3 is to find the linear velocity in the x and the y. Using the formulas, y equals velocity final times time minus 1/2 acceleration in the y times time squared. And the other equation, x equals 1/2 v initial plus v final in the x times time, you can find the final velocities. Step 4 is to find the angular velocity in the x and the y. So using the equation, tangential velocity, which is also linear velocity, is equal to radius times angular velocity. You can plug in the linear velocity and divide by the radius to find the angular velocity. Step 5 is to find the linear kinetic energy. So using the velocity final on the x and the y, use the Pythagorean theorem to figure out what the total velocity is. It's important to note that the sign at this point doesn't matter because in the kinetic energy formula, the number is going to be squared. So the sign won't really go into account. Okay, step 6 is to find the angular kinetic energy. So using the Pythagorean theorem again, use the x angular velocity and the y-angular velocity to find the total angular velocity, and then plug into the angular kinetic energy equation. Step 7 is to find the total kinetic energy, which you can get by adding the linear kinetic energy and the angular kinetic energy. Step 8 is to define the percent of linear kinetic energy in comparison to the total kinetic energy, which you can get by dividing the linear kinetic energy by the total kinetic energy and multiplying by 100. Step 9 is to define the percent of angular kinetic energy in comparison to the total kinetic energy, which you can get by dividing the angular kinetic energy by the total kinetic energy and multiplying by 100.
So Diana, can you break down what we're going to be doing today? Unless you don't understand your Okay. Dad, what up? Good. A little too aggressive.
Admit you made that whole story up.
No.
You started that fight. You calling me a liar?
I ain't calling you a truther.